Okay, so I like to do everything in degrees for these, but let me explain. If you have a coordinate plane with degrees, right? 0 degrees is right here. Then as we keep going, there's 90 degrees, 180, 270, 360. If you're going counterclockwise, and counterclockwise is the positive direction, right? So if I draw an angle here, this would be 30 degrees, right? Whatever. If I draw it here, this angle would be 90 degrees. If I draw it here, maybe this angle is 150, okay? If I go the opposite direction and I give you a negative angle, we're going to go this direction to draw it. So if I draw like a negative 30 degree angle, you're going to go this direction. So let's say it ends up like right here. That's negative 30, okay? If I do negative 190, so you're going to go, okay, 90, 180, negative 190 is probably about here, right? So it would be that direction. So the first one they give you, hang on, let me look at your text message. Or it's the second one they give you, actually. Number 5 is negative 230. Okay, so negative 230 degrees is going to go clockwise. Okay, so where does negative 230 fall? So this is 0. If I go 90 degrees, I'm right on the y-axis. If I go negative 180, I'm here. Now I can't go to 270 because that's too big because we're only going to 230 degrees. So 230 is going to fall somewhere here, right? It's going to go all the way from here and stop right there. Okay? What they're looking for is once you draw that angle and where it lands, in what quadrant, you're going to drop down a line to the x-axis, always to the x-axis, and they want you to find this angle right here. And the way you do that is you know that this is negative 180, and we stopped at negative 230. So what's the difference between those, right? So we have negative 180 minus negative 230, and that would be 50 degrees. Okay, so that's how you get the ones in degrees, right? I can do another one for you. Let's say I gave you, I don't know, 240 degrees, right? So let me erase. Well, I'll leave that stuff up there. We'll just use another color. So 240, we're going to go the positive way. If I go, I'm starting at 0, right? If I spin a spinner, think of this as a spinner and you're going to flick it. If it goes 90 degrees, it's going to stop right there. If it goes 180, it's going to stop right here. I can't get to 270, that's too far, so it's probably going to end up here. So let me draw this line here. That is going to be 240 degrees. You're going to always draw a line to the x-axis, and I'm looking for this angle right here. Well, I'm going to use the two numbers I have. I'm going to use the 180 because we drew it to the 180 line. And I'm going to subtract that from 240. So 240 minus 180 is 60 degrees. That's what this angle would be. Okay, so it's always like kind of draw it where it lands, right? And then see, like draw a auxiliary line to the x-axis. Even if I gave you like a 400 degree angle, okay, think of a spinner. You start here. This spinner is going to go all the way around because that's 360, right? And now we're going to have another 40 after that because 360, we've got to get to 400. So that's going to end right here. And we already went all the way around and we only went 40 more. When it lands in quadrant 1, it's kind of easy. So that's 40 degrees. Now, when they give you the radians, I think it was 19 pi over 5. I know your teacher did it in radians. If you understand the degrees, I would personally use degrees. You can do it on here, but our brains think easier in just, integers. So what I would do is change it to degrees. So multiply by 180 over pi. Change it to degrees. Go do what I just did, and I'll do that with you, and then convert it back to radians. So to convert from radians to degrees, you multiply by 180 over pi. I'm sure you know that. And so if we do this, we know the pi's cancel. So 19 times 180 divided by 5 is 684 degrees. We're going to plot that, okay? I'm going to use this coordinate plane right here, actually, so that way we can leave the other one. So this is 0, 90, 180, 270, 360. Okay, so 684. First of all, I know I'm going to go all the way around once, right? Because that's 360. So let me just take off the 360. And what am I left with? 324. Okay, so now I have 324 degrees left because I already spun my spinner all the way around. It's frozen right there, and it's going to go another 324. It's not going to stop there. It's not going to stop at 180. It's not going to stop at 270. It's going to be over here. So we're going to draw that line here. We're going to label it as 324 degrees. But that's not our answer. Our answer is always after we drop an auxiliary line to the x-axis, always to the x-axis, what is left? And then that's where you're going to subtract those two numbers because you're the number you're closest to the x-axis from. So 360 minus 324 is 36 degrees. Now she doesn't want it in degrees. I think it's easier to do in degrees. So now I'm going to just convert back to radians by multiplying by pi over 180. So really all you're doing is 360 over 180 and getting a reduced fraction. So it's pi over 5, which is what your teacher had on that paper. If that makes sense. Convert to degrees, find it on a spinner. It's like you're spinning a spinner, and draw that triangle up to or down to the x-axis. If you need another example, let me know.
Wait, they don't love me like I love you.
Nicholas, I'm still recording.